Okay, so the easiest way to do this, and you may just be able to do this in your sleep right now, well, maybe after you practice. The first thing you will end up doing is find the partials, okay? Because for almost all the problems in this section and in this chapter, you will have to find the partial derivatives, right? So try to find the partials first and evaluate them at 1, 0, okay? And they will give you exactly what you need, right? By the way, you should also identify this is x naught, that's 1, and y naught is equal to 0. And we actually haven't, maybe I should do this before we get into this, right? We actually have to calculate f at 1, 0. That's your z naught, okay? Because that is the z value of the point of 1, 0. And so that's 1 times e to the 0th power. Remember, e to the 0th power is not equal to 0. Okay, so the point we're looking for is 1, 0, 1. Okay, and then f sub x is, now this is a little tricky because remember you have, basically this is equal to x times e to the x times e to the y. No, it's not, is it? No, it's not. It's x times e to the xy. All right, so because you have a product, you have to use the product formula for x. The derivative of the first times the second plus first times the derivative of the second. So let's try to look at the partial derivative with respect to x of e to the xy. That's e to the xy times the derivative of xy with respect to y. That's the inside function, and that's y, right? I mean, if this was 5x, you will see 5 in front when you take the derivative. So if you have e to the xy, and if you take the derivative with respect to x, you get y times e to the xy. So that's your partial derivative. And then the second one, f sub y is, now remember, in this case, x is considered a constant. I don't have to apply the product formula. I hope you understand that. And then you take the derivative of this with respect to y. E to the xy still remains, but then you have to multiply this by the derivative of xy with respect to y. And that's the constant x. So this is actually x squared e to the xy. Let's evaluate both at 1, 0. And I use this long vertical line. I find this to be very convenient notation. I just like it. So, all right, so the first one is 1 times e to the 0th plus x, 1 times 0 times whatever, okay? Because that's going to be 0. And the next one will be 1 square e to the 0th power, right? So the first one will give you 1 plus 0, which is 1. Second one give you 1 times 1, which is 1. Right? So you need to have both of these in order to calculate or to find the approximation. Now remember, the linear approximation is simply z naught plus fx dx plus fy dy. This is maybe the easiest way to remember that, okay? Because this part, remember, is dz, right? So if you apply this in this problem here, this will be, remember, z naught is equal to 1. You got a bunch of 1s in this problem here, unfortunately. That times 1 times dx. Now dx is x minus x naught, and x naught happens to be 1, another 1. And then fy is 1, and then dy is y minus y naught, which is 0, okay? Because there's so many 1s, let me just color code this. This 1 comes from this, okay? And this one is that thing, okay? Maybe I should go this other way. So this goes to that. And then another color here, this one is going to that one, okay? And so that's what this is. And this is x naught. And this is y naught. And this is z naught. Okay, so the linearization of this function f. And by the way, f is a very complicated function, right? I mean, it's a product of x and an exponential function involving x and y. So it's not so easy, especially without a calculator, to figure out f of 0.99 comma 0.01. But the linearization will give you a fairly good approximation. Let's simplify this. It's 1 plus x minus 1 plus y. All right, so this is actually x plus 1, x plus y. That's it, right? This is very simple. And by the way, if, you know, because it's a linearization, it can't be quadratic or anything more complicated than that, okay? So once you start seeing things like x squared or y squared or anything like that in your supposed linearization, you know that can't be right, all right? So you have to remember that. Make sure that what you get is actually a linear function in x and y. So what did I say this was? X plus y? Yeah, x plus y, very simple equation. Approximate, all right, so let's approximate f of, what was that? My question was 0.99 and 0.01. You can do this in your head, right? This is simply x, you know, y, right? So it's 0.99 plus 0.01, and that's precisely equal to 1. And that is the answer. 1.00 is your approximate answer. Okay. Now, it always helps, or maybe, you know, if you're just curious, you want to find the actual value. Certainly, that's my case, the case with me. Actual value is this. The equation was x times e to the xy, right? So the actual, so approximate this what I'm saying is this is equivalent to that, right? But the actual number, if it's equal to, that's 0.99 times e to the 0.99 times 0.01, okay? And you can calculate this if you like, and you get the answer of, the answer turns out to be 0.999849671. So you can see that we were very close to the actual value because we used a linear approximation correctly. Okay, so this is how you can come up with this. And by the way, if you want to look for the tangent plane, I mean, maybe you can do that too. Right? The tangent plane at this point 1, 0 is equal to, basically all you have to do is, you know, this is your z, right? And you can just work out z is equal to xy, right? So z is equal to xy, i.e. x plus y minus z is equal to 0. That is your linearization or the tangent plane. Okay, but if you want to take the direct way, the way that I gave you, the formula I gave you at the beginning, the way you figure this out was, remember f of x is equal to 1 and f of y is equal to 1, right? So your normal vector will be 1, 1, negative 1. And the point you should take is the point P is 1, 0, 1. So you can do 1 times x minus 1 plus 1 times y minus 0 minus z minus 1 is equal to 0. If you want to do that, it's x minus 1 plus y minus z plus 1 is equal to 0. And that reduces to x plus y minus z is equal to 0, which not surprisingly is exactly what I got here. Okay, so this is the tangent plane, which of course is, if you solve this for z, you get the linear approximation. Okay, so that is what we can do. Now I have a few extra problems I'd like to work on, and then actually I would like you to work on. And then I have a little segment on error estimates, which you would need to know, and they have to do with partials. So I need to get to that as well. All right, let me get you to this problem here. All right, so maybe I'll give you another problem here, which is to find the linearization, which means the linear approximation. Find the linearization for this function, f of xy is equal to e to the 3x minus cosine of y at 0 pi. Now remember, you have to have, you know, some point in order to have a linearization. So go ahead and try that. and then we'll come back.